This talk's a little bit different for me. In the past, I've talked a lot about scalability and high performance kind of situations. This talk came about partly from a situation at work where we had a QA environment and continuous integration. As Richard was talking a couple talks ago in here, you run some tests, unit tests, maybe they take 3-4 hours after you check in some code, and all the panels light up red and you find out that 87 things are broken now. And you made one small change and checked it in and went to lunch, and it took a couple hours to find out that nothing works anymore. And it turns out it's nothing to do with your code. Somebody deleted a directory, or the database server just stopped accepting connections, or something stupid like that. And if you had known ahead of time, that the environment had gone bad, then you could have saved that time, set things up properly, run, and then gone to lunch, that sort of situation. And there's always that horror when everything turns red, and you think, what? I couldn't have made that many mistakes, right? And it seems like the majority of the time, it's the environment, not the code. Like, you're generally not changing that much code. But last year, Fred Ebert, who always gives thought-provoking talks, talked about supervisors and how an application is managed by the supervisor hierarchy. And the way that you learn and understand how your application works, how it should work, and how it fails is by tweaking the supervisor hierarchy. You subdivide the problem, you analyze what the dependencies are, and then through trial and error, maybe whiteboarding, you work with your team, and you develop a hierarchy that lets you know which part of the application is working, which part isn't, and let things fail so that they don't propagate to other parts of the application and that they restart automatically. And it's sort of this magical thing about Erlang and Elixir that by having the supervisor hierarchy, it just becomes resilient to common errors. And it works because of the foundational elements within the VM of detecting errors and crashing, and the principle of just let it fail, crash early, that kind of approach. So at the end of his talk, he concluded with the question, what if supervisors were more than just about Erlang? And that got me thinking about our QA environment. He was describing a mechanism where you had a proxy process, which represented an external physical world item. And then you could use a supervisor to manage that proxy process. And if the proxy somehow detected an error in the physical real world, it could crash, and then the supervisor would restart it. And you could use that to reset some physical world thing. And in our QA environment, the initial thought was, wow, that would be really cool if I had supervision of the QA environment and somebody goes in and deletes a directory and it would just crash and put it back again. Well, it turns out that that's probably too aspirational of an approach, because now you're fighting each other, and QA is totally unstable because it's doing things automatically. And there's dependencies that could cause other consequences if you were to automatically restart and replace things in QA. But the concept is similar. Supervisors are managing Erlang processes. What if I could manage just the observation of the QA environment? And now it's no longer about restarting, though. That's one of the key fundamental concepts behind supervisors, is they're there to restart so that occasional transient errors can reset to a known state. And now things operate again, and as soon as you wander off into an area where your code doesn't know what to do, it stops and restarts back to a known state. There's another Fred Ebert blog post about supervisors restarting and how to have that happen that you should look for. Starting from a known state is the real key. So this is an attempt to supervise the QA environment. And the stability really depends on resources and dependencies and preconditions in the environment. The CI failures are often stability failures and not so much code failures. What you want to do is separate stability failures of the environment from actual unit test failures and CI failures. And we're not going to be restarting and resetting QA, but we're going to be detecting when it's wrong and then allowing humans or automated software to query the state of the QA environment, find out what's wrong, what the history of what has happened, and then be able to correct it in a way that maintains stability and management control. There's some sketched up code on GitHub that's growing as I work on the problem. Originally, I envisioned an API and that you could just call the API and use that. But supervisor hierarchies are sort of statically created, and you have to think about them. You have to really craft them and customize them to your application. And it gets even more so important with a QA environment. Every environment has different elements to it. It may have different databases or socket connections outside of the environment. And you really need to customize what you're testing for so that you can guarantee that the QA environment is set up properly. So the goals are to recognize when CI is not going to run properly and just circumvent having it automatically kick off. What we want to do is keep a history of the stability changes that have happened in QA. So what I would like to do is today I notice that QA is incorrectly set up. I do a query, I get a history. Over the last week, it's changed twice. The state is flipped to an invalid state, and then it's back to a valid state, and now it's in an invalid state. Now I can notice a pattern and maybe correct some meta situation that's causing this conflict. Generally, somebody added a new tool and flipped something somewhere, and nobody else knows that new tool's out there yet, and so you have to kind of discover these things. So the other thing is that you might have transient errors in your QA environment. You might have a Redis box might be down right now, but you made some changes to the code that don't involve that part of the tests. You should still be able to run continuous integration tests for some other aspect of the software that doesn't involve the part that's down. So by providing a status API, you can automate the testing so that it only tests portions of it that the CI environment is currently stable for testing. Again, avoiding those misleading CI failures. So there's different categories of dependencies in the QA. Often there's a directory layout that's assumed, maybe a QA test user that has to be set up, and then some places where logs and data are sitting so that the unit tests can actually run. And then what often happens is you'll run your unit tests and they'll generate gigabytes of log files if they're running for a long time. And so an hour into it, you run out of disk space and you find out that you have to clean something up, start over again, lost that hour. It'd be nice to be able to codify that and know how much space you're using ahead of time and test for it before you actually do a run. So we're trying to capture the instabilities and formalize them into a supervisor-like hierarchy of rules and tests, which become documentation for how the QA environment should behave. And that way, if you control that code base the same way you control your production code base or your unit test code base, you can look at that and use it as documentation for how the QA environment works and incrementally enhance your QA environment so that you can test more things and know how it's working. Then often there's a bunch of services that you might need. You might need access to Git to fetch versions of code, and databases that you're using, test accounts and configuration data. All that stuff often has to be set up properly. And lots of times you'll have different versions of a database, and one QA suite might use a version that's pre-canned with some data, and another suite might use a different version of the database that's pre-canned with different data. So you would, over time, gradually customize that to your environment. So the idea is to have a library of building blocks with periodic polling to check for dependencies. So in the past, where I've worried about throughput and volume and scalability, now I'm talking on the order of like once a minute, once every 5 minutes. You route around in the directory structure and look for anomalies, and then you wait and poll again and try that again, and just keep a record of what's changing in the environment. So now you can use more of the tools without regard to scalability issues like GenEvent. A lot of people avoid GenEvent because they think it has scalability issues. If I'm running something once a minute, once every 5 minutes, it doesn't really matter. You can use it without regard to that. And, but there is one thing about this. It's nonstop. You want to leave it running forever, and you shouldn't be generating log files checking the stability of the QA environment, because now you're generating metadata that you weren't accounting for when you're testing for stability, and you're going to throw that into the mix, and it's going to cause the same problem all over again. So the approach is to maintain a bounded queue of history changes internal to the polling dependencies. And that way I'm not using up disk space. You can periodically query it, squirrel that away into a database somewhere offsite, off that QA environment in a different location, and then use that to guide your decisions about running CI. So to make the dependencies work cleanly, you're going to want a supervisor hierarchy and polling parameters based on the frequency that matters for your environment. And so that's why it's a little difficult just to provide an API. In one environment, you might be able to have a GenEvent that's got 20 entries in it, and those can just run serially. But if you have tests that take a while, you don't want them to run serially. You want them to run concurrently. And so you're going to have to arrange the supervisor hierarchy. So rather than an API, what I'm providing is an interface to generate supervisor child specs. So you make a call, generate child specs, and then install the child spec into the root supervisor yourself. And that's how you customize the application environment to be able to test the QA environment. And then, in addition, you're going to summarize the status in the way that's important to you for your application. So if my system has 3 aspects, one is the local data stores, and another is databases, and another is internet access, then I might have a status that has those 3 elements as part of the status structure. And if I'm using JSON, or if I'm using an actual Erlang structure, I would express it as that. The talk we just finished talked about using a genstatum, and there were questions about, do you use an atom for a state, or do you use a data structure in the data? And what you really want is atomic summaries of your current status. So you, like, QA is valid, or QA is partially down, or QA is just not working. You want to be able to look at one thing and know whether you're in a green or a red state. But then you may need additional information to make decisions about which CI tests can run. If I'm in a partially degraded state, I can know immediately I'm partially degraded, and then query for more detail about the status so that I can run some CI tests and not other CI tests. So that's, in a genstatum sort of case, having both the atomic state and the data which has details about why you're in that state. You can summarize, using more knowledge from the detailed info, the current state of the environment. So here's the basic structure. There's a root supervisor, and I use REST for one. This is my Erlang avoidance scheme that I fall back on. In Erlang, I don't try to I don't try to avoid problems. I try to make it so that problems don't occur. Often, if people are writing temporal logic, if this, then that, whatever, they're trying to avoid some situation that they know is a problem. And generally, when they get into that branch, they don't really know what to do because they were trying to avoid that situation. And so you haven't really solved the problem. What you like to do is create serial dependencies of startup so that the situation you're trying to avoid can never arise. So I have a status API that I'd like to query, but if I'm in the process of starting up and that status API doesn't exist, and I try to query it, there may be a transient error, and then I have to deal with that transient error. And if I register it on a registered name, the same thing could happen. It might crash and then restart, and there'll be a gap where it's not registered. But if I use a REST for one and start the status API in a state that says QA is not ready, then I know any code I write after that can't be running unless the status API is already running. And so then I can just call it without any transient errors. I know it's already going to be existing. So the first thing I start up is the API that tells me, what's the current status. And then the next supervisor is the dependency polling supervisor. This is a supervisor where you're going to install your polling child specs. And it starts out with an empty list of child specs. And so it can start up very quickly, right away, and then the monitor controller is the thing that's in charge of the application. It decides what child specs you want, what order to set them up, how to install them, and then sends the events which trigger the whole mechanism so that everything is in place. If the monitor controller crashes, I don't lose the history in the status API. It's still running. And the monitor controller can restart and query the system and see what state's it's in and reinstall some child specs. So this is all just to create a time order dependency so that I can make assumptions and not have to have defensive coding techniques in the application. So one of the key understandings here, though, is, and it's not apparent when you look at supervisors, there's one-for-one supervisors and simple one-for-one supervisors, and one for all, and then there's REST for one. And REST for one is the only one that actually has an order dependency built into it. And so you can't dynamically add children and then have a child crash and then add it later. It'll be in the wrong order for REST for one to work properly. So if you need REST for one dependency polling, you actually have to statically install a dynamic, serially ordered set of child specs. And so that's why the simple API approach doesn't really work. You need to be able to specify your hierarchy and do that through the child specs. So the monitor controller sets up the application logic, as I was saying, and it generates the required supervisors, installs them in, and then provides a summary interface to the API status. So the API status is going to return you raw state of QA. And in your monitor controller, that's where you're building the logic, the knowledge about your QA environment. So in there, you might set up functions that say, if the current state is partially degraded and Redis is currently not available, then these CI tests can run, and these other CI tests, they can't run. And so you would build in that logic, and that becomes the documentation then of how your QA environment is set up. And this gets back to the statum and the state machine kind of approach. Now you could draw a diagram that says, hey, if this is down, I can't do this. And everybody can look at the picture and point at it and argue about whether that's right and change the order of it and so on. That's the real advantage of using a state machine, is that it becomes a pictorial documentation evidence that people can look at and argue about. So the dependency polling, I just use simple timer send intervals and have that statically compiled but configurable. And the one thing to be careful of is that the gen servers that are doing this polling are independent of each other, and the cycling may be independent. So you need to make sure that there aren't any cross-server dependencies that get out of sync. basically all you do is push everything that's dependent on each other into one gen server and let it check all, if you need to check a directory hierarchy, it should check everything that's dependent on the root of that hierarchy. And then avoid logging, because this poller's running forever. And here's a picture of the bounded queue that's internal to the pollers. There's a model, which is a module that you implement that says, hey, if QA environment is valid, if these dependencies are all present. So you just implement a model module, plug that into an instance of a gen server, and then set up the timer frequency, and it'll automatically record every time the validity state changes. It'll add a new entry that says the state is now this on this timestamp. And so then if it's running every minute, it might only have 3 entries in the last week, and it's not taking up much space. And I bound it at, whatever makes sense for you, and then you can just always query it and have a history. And I would keep a database, month by month or whatever, and that way you could track it. So that's basically how the model module works. In there, you get creative with how you're going to express the state. And you might just start out with it's valid and it's invalid and build it up from there. Now it's 5 states. Now it's a big structure that tells me more details. And the status API then is, if you look at this diagram, the other feature is that the status API starts out first so that there's a PID reference that can be passed by the monitor controller into the dependency polling. So now dependency polling can inject into the status API. So when you get down to returning a status back, you've got snapshot updates that are current based on the dependency polling, and you've got your summary, which has extra knowledge attached with it. And then you can decide whether you're stable enough to run tests. And your CI script should query that API and make its decisions using that information. So that's how the automated testing would occur, and it would skip any that aren't set up to run right now. So the benefits for the CI testing, you get a history of the QA environment stability, which is available at all times, and you should record it offline so that you've got graphs and things just like you do for production. You get higher confidence that test failures are non-environment failures, they're actually code changes. And the evolution of the monitoring code gives you the documentation that as team members come and go, it's codified as corporate knowledge. The dependencies are explicitly described, especially if you use a state machine. And the visibility of QA becomes similar to your production graphs. Any questions? Yes.
What are the specific reasons that logging should be avoided?
So the question is,